Well, friends, today we're talking about section 5.3. This is the first video in our series, and we're dealing with the fundamental theorem of calculus and interpretations of the integral. And so I want to start out with some integral, and let's let v of t be velocity in miles per hour. And I'm just going to draw a little graph for us. And we'll just see what happens here. So this will be time in hours. Here we'll have miles over hours. Should probably put the units here. And let's say we have 0, let's have 2, and let's have 2.5. Now, from 0 to 2, all of this area here, and I just want to remind us that any area on this graph, the height is going to be in miles per hour. The width is going to be in hours. And so by multiplying those together, we'll have miles per hour times hours. Murder occurs, and I get glorious miles, which means that the area between the curve and the t-axis is the distance that we've traveled. Now, so if I said the integral from 0 to 2 of v of t dt, that would represent all of this shaded piece. And maybe I'll make a little key here, right? That's all of that shaded area. And this is some positive number. And what this is, that represents the total distance traveled from time equals 0 to time equals 2. Yeah? Okay, love that. So if I was going to think about this velocity here, this one, which I'm going to hash in the other direction, that's going to be the integral from 2 to 2.5 v of t dt. And what is that? Now, instead of traveling away from my target, I'm traveling back, yes? But still, this is the distance we travel back from t equals 2 hours to t equals 2.5 hours. Okay, I can ask us one last question, and then maybe I'll just say we're going to look at the integral from 0 to 2.5 of v of t dt. So I went away from home for 2 hours. I came back for that next half hour, and the area, the signed area, the positive area above, the negative area below, is going to give us, maybe I could say like the net distance. The net distance I travel over the first 2.5 hours of this trip. And I'm not going to give a sign here as to what it is. You know what it is we're talking about. So I love these interpretations. These are very strong. I want us to think about, though, that the velocity has a parent function, yes? If I have s of t, which will be our distance from home, t hours after our trip, well, certainly S has a relationship with V, doesn't it? S prime of t is equal to v of t. Yeah? Derivative, miles per hour, and we have this. So is there another way to describe the total distance I've traveled from home, from 0 to 2, but this time not with the integral, this time with our position function? And I think we sure can. I think we could say that this is s of 2, the total distance we've traveled in the first 2 hours, minus the total distance we had traveled at hour 0. What about this one? The distance we've traveled back from t equals 2 to t equals 2.5. I think we can do that as well. That I've had some distance at 2.5 hours, and I'm going to subtract from that the distance that we had at 2 hours. And that should be a negative answer because at 2.5, I'm closer to home than I was when I was at 2 hours. Similarly, the total distance I've traveled over the first 2.5 hours of this trip. Now, sure, I traveled to 2, and then I traveled back, and so I'm closer to home, and so I could say that we were at s of 2.5 minus s of 0 for the net distance that we have traveled from 0 to 2.5 hours. Our work previously has led us to the fundamental theorem of calculus. And if I have the integral from a to b of any function, and really, I like to think of this as some derivative, right? Where I'll have some output over input multiplied by some input, and we'll get the parent function evaluated at our second endpoint minus at our beginning. The relationship between capital F and little f, just to be very specific, is f prime of t will equal little f of t. So I'd like to make a new function just to begin playing with this. And so how about f of m be the fluid ounces I drink after I travel for m miles. Fine? And so if I said, hey, how many fluid ounces do I drink between, let's say, 160 miles, what you could certainly do is you could say, well, f of 100 was the total fluid ounces I drank from 0 to 100 miles. And I could remove from that the fluid ounces that I drank over the first 60 miles. And I would have the change in beverage consumption between 60 and 100 miles. Another way, though, to think about this would be to say, I'm going to look at capital F prime. And the units of that are going to be fluid ounces per mile. I'll have 60 miles and 100 miles on my graph, and presumably this is going to be up. Of course, the units right here, they're going to be fluid ounces over miles times miles. The miles murder one another, and I am left with just fluid ounces, and that's this area right there. How do I represent that area? That's the integral from 60 to 100 of capital F prime. And really, I can use any variable in here, but I'll use m dm. I've expressed this idea, the fluid ounces of drink, in two different ways, with the parent function as well as with the derivative. And so the two are certainly equal to one another.